Hello folks. This lesson we're going to look at adding and subtracting rationals. So, adding and subtracting, one of the most, or the two most evil operations in all of mathematics. And the reason they're evil is because you cannot add and subtract things unless they are the exact same type of thing. And when it comes to fractions, what makes them the exact same type of thing is having what we all know is a common denominator. So we're going to start off easy and work our way to some more difficult examples. So looking at the first one here, 3x squared plus 3 over x squared plus 5 over x squared minus 2 over x squared. As you can see, the denominators are already the same in this case. So when you have a case like that, you just add the numerators, which I would like you to start considering that you can write like this: 3 plus 5 minus 2 all over x squared. Now, I know you could have done that in your head, but if you can start to visualize it as being that, it will help for some of the later examples. 3 plus 5 is 8. 8 minus 2 is 6. The answer is 6 over x squared. Our restriction, which I'm going to write up here, is x can't be equal to 0. Now, I'm going to drop restrictions for this lesson simply because I want to focus more on the aspect of adding and subtracting, if that's okay. So for the second example, we have a denominator of 2 and a denominator of 3. And this is an addition or a subtraction, addition in this case. Therefore, we need a common denominator. So we've done situations like this for many, many years. How do I find a common denominator with 2 and 3? Well, you want to find the lowest common factor to 2 and 3, which would be 6. So we're going to multiply the bottom here by 3, the top here by 3, to change the bottom into 6 and to keep the fraction proportional. And we're going to multiply the bottom here by 2, the top here by 2 for the same reasons. Again, just to speed things up, because we're used to doing this, I'm just going to simplify right away. We end up with 9x plus 8x all over 6. So instead of writing it as two separate fractions, as I was explaining above, you can write it all as one fraction right away, just putting it all over the common denominator, following the operation at the top, which was an addition, right here. And then we can simplify to 17x over 6, which would be our final answer. Now, what happens in a case where we have denominators that are rational, rational equations, okay? So denominators that are algebraic is what I mean. Sorry, these are rational expressions. We're looking at denominators that are expressions themselves, algebraic expressions. It's the exact same idea as what we have above. Now, one of the tricks to finding a lowest common factor is often just to multiply the two denominators together. So 2 times 3 came from 2 times 3. Sometimes that doesn't give us the lowest common factor, but sometimes, like in this case, it did. That's the technique we're going to use here. We want our denominator to be a combination of x plus 1 times x plus 2. That's going to be our common denominator. So how do we do that? Well, we're going to do it the same way we did up here. I'm going to bracket this, and I'm going to multiply it by x plus 2, and I'm going to keep the x plus 2 in a bracket. I have to keep the x plus 2 in the bracket because the entire numerator is multiplying the entire x plus 2, and the entire denominator, x plus 1, is multiplying x plus 2. So you just have to keep the brackets there. On this side, we're going to multiply by x plus 1, which was this denominator from that fraction. So we're multiplying x plus 1 by the denominator of the second fraction, and we're multiplying x plus 2 by the denominator of the first fraction. And we're doing that top and bottom. So it's the exact same thing we did up here, multiplying the 2 times the denominator 3, top and bottom, multiplying 3 by the denominator 2, top and bottom, in order to get our common denominator. So what is this going to look like? Well, we're going to have 3x times x plus 2 minus 2x times x plus 1, all divided, sorry about that, let me retry to do that a little bit straighter, all divided by the common denominator of x plus 1 times x plus 2. And now we're going to expand the top. Now we do have an issue with this negative sign. We've seen this before. When you have a minus 2 or a minus sign in front of a bracket, all of the signs inside the bracket are going to change accordingly. Okay, so be very careful with those scenarios. So let's expand the top. We get 3x times x, which is 3x squared, plus 6x, minus 2x squared, minus 2x. And one little trick that I do for these, and I've shown this before, is I'm going to use these little quote marks to represent that we're just repeating the bottom here without changing it, but it's still there. It just helps me remember that it's still there. And now let's write our final expression. So we're going to combine like terms. 3x squared minus 2x squared is 1x squared, plus 6x minus 2x is plus 4x, and that's all divided by x plus 1 times x plus 2. Now there's one more thing I should do. I should factor the top just to make sure that nothing simplifies. I can already see that nothing simplifies though, even if I do factor. So, but I'm going to do it just to show you. And that's what we would end up with if we factored it. But nothing's going to simplify if I factor it. So really this one could have been okay, but it's always a good idea to check it. If you're going to check, you might as well do it, right? So just to recap, the most important thing about today's lesson, sorry about that, is going to be how do you find a common denominator when you have expressions as your denominators that are algebraic. And what you want to do is look at all of your denominators and make sure that every denominator contains all of the other denominators as multiplications. So let's take a look at another one. So in this case, I've got an x minus 3 denominator and an x minus 4 denominator. I need a common denominator. Now to speed things up, you could do this, because you know that's going to be your common denominator, and then just realize that this x minus 4 is going to multiply at the top here next to the x. So we're going to have x times, so I'm going to actually do it in red so you can see. And then for the second one, the 2x is going to be multiplied by what? Well, the x minus 4 would have to be multiplied top and bottom by x minus 3, so we're going to put an x minus 3 here. And if you don't understand what I did there, please write the bracketed x minus 3 times the bracketed x minus 4 top and bottom, and the bracketed x minus 4 times the bracketed x minus 3 top and bottom, and you'll see that you'll end up with the exact same thing I have here. Expanding, we get x squared minus 4x plus 2x squared minus 6x, all divided by the common denominator. Then we get 3x squared minus 10x, all divided by the common denominator, equals, and I believe the only thing I can factor out of there is an x, so x times 3x minus 10. And now I'm going to rewrite the common denominator, x minus 3, x minus 4. Like so. Now a quick little discussion about using an equation editor. As technology gets better and better, those equation editors are also getting better and better. This would be a scenario where an equation editor would be quite useful, because so many things repeat. Like this line repeats itself here, and I'm just saving time by not writing it, but it is supposed to be written, right? So if you had an equation editor, you could just copy and paste and just change the numerator, and since a lot of the terms in the numerator stay very similar, that would also help things out. So this is where a benefit of an equation editor can come into play. And the more complex the equations get with repetition as you simplify, the more the equation editor is useful. Let's take a look at this one now. So this is one of those examples that I was talking about earlier in the week, where all of a sudden we have quite a bit of factoring going on. So we got to make sure that we're good at factoring. We can identify what kind of factoring it is and do it as quickly as possible. We do want to factor everything before we start, because it is possible that certain things are going to cancel out. Okay. So looking at the first quadratic here, it is a type 2 quadratic. So I'm just going to do the tree that I do over here. So it's 2 times 3, which is 6, and our middle number is -5. This is that combination that I've mentioned before, which is a little bit tricky because 6 and 1 will give a 5, but you have to make sure that it also gives the proper sign for the 6. So in this case, it's actually -3 and -2. So when we factor it, we get 2x times x, and then 2x times something, which gives -2 in this case, so that would be -1. And x times what equals -3 would be -3. Our denominator here is the difference of squares, so that's x plus 1 times x minus 1. For our numerator on this side, it is also a difference of squares, so that's 2x plus 3, 2x minus 3. And our denominator, the only thing that can factor out of that is a 2, so we get 2 times 2x plus 3. Now take a look at all of the things that cancel out here. We've got a, now be very careful, you cannot, not that it can in this case anyway, but you cannot cancel out diagonally when there is a plus, okay? So if this had been a 2x minus 3, it could not cancel out with this 2x minus 3 because of the plus. The plus is like a wall between those two. You can cancel out above and below, but you cannot cancel out diagonally, so which is different than multiplication. In multiplication, you can cancel out diagonally, but addition, you cannot, all right? So I just wanted to point that out. So here the x minus 1 will cancel out with the x minus 1. The 2x, oops, wrong one. 2x plus 3 will cancel out with the 2x plus 3. Let's write what's left over. I'm going to keep the brackets there because we're going to need them to find our common denominators anyway. So now, as we can see, our denominators are left with only x plus 1 and 2. Now, sometimes you'll be left with denominators that are actually going to be like, you know, another binomial here, which means you'd have to actually multiply by the binomial as well, okay? But in this case, we don't have to do that. So we're going to multiply the top and the bottom by 2. Let me use a different color for that, because that's the denominator that's missing on this side. Over here, we're going to multiply by x plus 1, top and bottom. So what is that going to look like? So we're going to have, and I'm going to distribute the 2 in because we know from previous examples that we're going to have to do that anyway. So we're going to have 4x minus 6 plus, and I'm also going to FOIL this at the same time just to save us some space, okay? So 2x times x is 2x. 2x times 1 is 2x, minus 3x is minus x, and then minus 3 times 1 is minus 3. And that's all over the common denominator of 2 times x plus 1. Whoops, I forgot the squared above the 2x squared there. Okay, so what do we have at the top? Let's collect like terms. So our 2x squared comes first. Then we have 4x minus x, which is plus 3x. And then we have minus 6 minus 3, which is minus 9, all over 2 times x plus 1. And we'd potentially want to try to factor the top just to see if anything else would factor from the bottom. If we get an x plus 1 show up at the top, then it will actually simplify with the x plus 1 from the bottom. So what is our top factoring going to look like? So we have negative 18. We need two numbers that multiply to negative 18 and add to 3. Those two numbers would be positive 6 and negative 3. So that top does factor. So we're going to have 2x times x, and then 2x times what equals 6. That would be plus 3. And x times what equals negative 3. It would be just negative 3. All over 2 times x plus 1. Now it did not factor. It did factor, but it did not simplify. But it's always a good idea to check just to make sure. And that is the answer to that one. So expect some work to go along with this. And that'll be it for today's lesson, and I will see you soon.